Right. He will start very, very soon. Right. He should start. Oh. Okay. Hello, everyone. Hey. Okay, we are back. Okay. So. Okay. Topic for today is learning programming with Rust, and this is targeted to people who are new to programming languages. So, who are new to programming languages. Today we will talk about mainly about assignments and branching topic. Okay. Okay. Programming is like writing mathematical questions, except there are some differences where, like for example, you are given a formula like this, equals to c. Y is where m is the gradient and c is the constant. This is a linear function that shows a relationship between x and y. You can actually write a program that does this kind of calculation, except you cannot plug this into a programming language that of your choice directly, because it will not yield result, because everything it's somehow needs to be known in order for the calculation to be carried out. So if we start from very beginning, so I talk about a lot about calculation because it is a very convenient thing to do programming. So we'll be doing a lot of calculations, like calculations, 1 plus 1, 2, 5, etc., etc. You can also do calculations on decimal numbers. We call that floating points. 0, like that. So what makes it, like, why do you want to carry out on how that in a program is because it's faster. Also, the calculation can be very complex, like over time. So back to the y equals to mx plus c thing. So when you are given suppose you are given m equal to 2, c 4. So if you want to find the value of y, just gonna get the value of y. So now you see the difference between writing a mathematical expression and writing a programming, because as you can see, everything on the right hand side needs to be defined, and you cannot write a statement where say y equals to m minus times maybe plus c. It will not work because the value of t is not known, so you cannot expect the program to return a value. So what this does is what we call assignment most of the time. Like we assign a value to a variable. In this case, we call it m. So besides storing a value, you can see that you can also store a result of a calculation here. So calculation of numbers, or I should say manipulation of numbers, is one of the things that you can do in a program. You can also do some text manipulation in the program, but I won't be covering much about that this series because there are some fun things about Rust that makes it a little bit different compared to other languages. So I'll be focusing mainly on numbers for now. I will be talking about things maybe in next tutorial casting. Okay, so the moral of story is you can do number calculations on in most of the languages that you see in the market. So for example, you can do like multiplication for 7, 8. Also do division or divide. Notice that all the numbers that I use here are integers. What would happen if you mix like integer with a decimal point number? It will give you an error in Rust because Rust is a statically typed language where we require everything that we work, like things that you throw together has to be in the same kind of things. So if we are throwing integer and float together, it will give you an error. So there are ways to work around this, but for now, let's just remember to not mix integer and decimal point numbers. So that's it. So what assignment does is it stores things into a variable. So the way you do that is you write a let. It's a keyword let followed by the name of the variable. It can be something very simple like mathematical, like x to 10. Can also be something long, ridiculously long, like this. And so when you call this a variable, it implies that you can change the number, you can change the value. Like in maths, you do a lot of suppose x is this, then what is y, and suppose x is another number, what is y. But you cannot really do this in Rust For example, this should give you error because these variables, they are assumed to be immutable, so they are basically more like something you cannot change despite being called a variable. However, if you really want to change the value, you just add another word after that, mute, which stands for mutable. X equals 10. Then try make it equal to 12 again, and it should work. X is now 12. Besides storing a number directly, as I told you just now, you can also store a result of a calculation. So X can be something like 3 at 43. X is now 40. Has to be each statement has to be completed with a semicolon. So X is now it, and everything that is on the right hand side can also fix a variable. So X could be, say, 20. Let's say we have variable y equal to 30, and X equals 20 plus y d. Right. Go back to the original example like I showed you just now. So in order to solve the equation, you need to provide whatever that is on the right hand, everything that is on the right hand side. Whatever that is not known by the compiler, return an error. So in order to get a value for y, need to provide m 1 c 3. You can then find the value of y, m x plus c. You can see the precedence of the calculation follows pretty much like mathematics, where multiplication is done first, followed by addition. So if you want things to be done first, for example, you have like times 7 get to 23. But if you want 2 plus 3 to be done first, just enclose it within a pair of parentheses, a pair of brackets, and should give you a different answer. So this is mainly what assignment is. Assignment. Stores the value. So value of right hand side. X or if you want, change the value of the variable data. And value execute. Statements. Semicolons is like period sign in English sentences. It usually denotes the end of the assignment instruction or some other operations that we will learn in the webcast. So this is pretty much it, I suppose. So to recap, you can do mathematical things in most of the programming language, but in this case we do Rust, so you can do addition, 1, 2, subtraction, we can do multiplication, and also do division. It should work. Of course, there are other things that you can do, like you can do square root, you can do raise a number to power, etc. But I will not be covering that for now. And if you like to, you can always refer to the presentation that I will share later. So now that you kind of know what assignment is, we should proceed to show you how you actually do it. So these days you don't need to install anything in order to learn programming. What you do is you go to this website called Rust Playground. The URL is listed here as play.rust-lang.org. This is where you can experiment or do some learning on your own without having to install Rust in your computer. So whatever that we do here, like printing the result, cannot be easily done here because we need something like a command print out things to the screen. So in this case, when you go to this website for the first time, you will see this thing that looks very scary. So if you run this, you will see that hello world is printed to the screen, or standard output as a screen. So we can use this to actually replace what we see here. So if you want to do display the result of a command, all you need to do is this. Then you will see the result of the calculation displayed in the screen. So in order to recreate this, let's say the first time you log in, it's empty. there are some things that you need to remember for now, but it will become something here for you to understand later. So in order for a program to execute, we need something called a main function. So a function is written as follows: function and then followed by the name, which is main, a pair of brackets, pair of braces. Alright. What this does is probably not important to you right now, but it has to be there. Then you put your print line statements inside the braces. It has to be inside. So the command to print it out on screen is called line ln, a pair of brackets, pair of quotes, double quotes, quotation marks, and then pair of braces inside the quotation marks, a colon followed by question mark. Then we go outside of the double quotation mark, put a comma. Then you can put in whatever that we put here, all the calculations. For example, we put this in and end the sentence with a semicolon. You run this and you see the result displayed right in exclamation mark here. Look. Yeah, you will see the result, same exact result displayed on screen. What happens if you don't do this? If you don't do this, you will not see it printed on screen, and you will see some funky errors. We somehow learn something, but this will be covered later when we talk about reusing our code for other purposes. So just remember, you want to print something on screen, the print line, exclamation mark, pair of comma, inside comma a pair of semicolon, braces, your calculation. Other things like assignments can be directly done. It will not be happening inside here. It will be outside of inline over. And so let's say if you want to display the value, you will have it. It's a bit slow, but it usually gets the job done. So also declare something that is mutable. a real variable. Or y and run it, and you will get a new value of y. Each line corresponds to one print line here. So the first one refers to the first one. This 10 refers to the second, refers to the third, fourth. Notice that the value of y changes, right? The print line commands is the same. Yes, the value of y is changed here. Therefore, the second print line prints different value for y. So, this is it for assignments. So, it's for you to store value, whatever that's on the right hand side of something we usually call equation in mathematical context. Store it inside a variable that is on the left hand side. So because we can change the value anytime, so this is where it differs from a normal mathematic writing, because in mathematics you cannot really change value like whenever you want. So this is where it's different. Okay, now we move on to our second topic of the day, which is branching. Branching is, before we go to branching, we talk about Boolean binary operations. Like if you learn logical expression or anything that deals with true or false, then this is where it is useful. For example, you want to know whether a number is odd number or even number, you usually go by checking whether it is divisible by 2. I should go to here instead of sticking to the original. It's not. So number, you want to check whether number is, say, have a number m is 8. Want to know whether it is divisible by 2. The number is divisible by 2. The remainder of the division should equal to 0. This is the meaning of the operator here. So when 8 is divided by 2, the remainder is 0. So it should give you true for this expression. It's not important. True. should be true. So if my m is maybe 7, I divide 7 by 2, and then I check whether it is equivalent 0. So it's false because 7 is an odd number. You can also do other, so given true, false, and false, you can also do other logical operations, like something that is true and get a false. An operator explains that requires that both sides of the expression to be true in order to yield the true value. Otherwise, it returns a false. So we can also do or operation. Fourth one is true. Or requires either side to be true, return the true. So knowing these operators, the equivalent, and logical OR, we can proceed something we call branching. Branching is like, so far you see that all the things that defined here are executed sequentially one after another. So what branching does is it executes only a portion of predefined statements depending on condition. So the way you proceed this is, right, if it's a keyword, we call this a keyword if, let, mute. These are all keywords where you need to spell it exactly like the specification says. So you cannot have something like if. This will all not work. It has to be in this form, the preferred form. If followed by condition, and we open and close the braces, which you may find familiar because we use braces here in the main also. We put all the subsequent statements, commands into it. So let's say I would like to number when the condition is met. So the condition has to be something that yields a true or a false. So in this case, you can either put this or we can do true or true or false, or even just the value true, false. So if this part is optional, you do not have to do this part, else and another pair of braces. This is optional. This part, you do not need this. It's not. You actually do not need this part. The program will work by itself. But if you want to do something where the condition is not true, in this case false, you will print another number. Let's put something more sensible here. It's even. Right, you will see this part is executed, but this part is not executed. This is what we call a branching, where for now the value of m is 7. 7 divided by 2 gives a remainder of 1, which is not 0. So this part that should be executed when this condition is true is not executed. However, this part that expect this to be false is executed instead. So what happens if I don't put this? Nothing get executed. Yeah, this will not get executed. Then it will proceed to the next thing line. But what if you need to do something more than just else? But for example, you need to check whether a number is divisible by 2. If it's not, then we check again whether it's divisible by 3. If it is not, what do we do? You can do this. You run this. Remember, m is still 7. I have not changed the value yet. So you can see that this is executed instead because 7 is not divisible by 2 and it's not divisible by 3. So this is not executed. I will proceed by checking this condition. This doesn't 7 doesn't satisfy this condition as well, so it fall back to else. Like previously, you can also ignore. You can also not write this. Then these two lines will not get executed, and proceed to the. So else is like fallback that make sure something is executed out of this big piece of code here. So usually this is used as the last resort thing that you might need to handle in your calculation. Otherwise, you would not be writing this else clause, for that clause. You also notice I write a lot of things like putting down notes like that begins with 2 slashes. This is what for comment. A comment doesn't get executed. Compiler, the computer will by default disregard whatever that follows after these 2 characters, the slashes, until the end of the line. So it can be done in the beginning, the line, or towards the middle of the line. Whatever that follows it will not be executed. So that's it. So this is what we call branching. So to recap, branching requires an if keyword followed by a condition followed by a pair of braces. Then we put things done inside the braces, inside this pair of braces. When the evaluation of the condition and whatever that should be done is done, it will continue with the execution below branching top. And condition needs to be something that gives you a true or false. So for instance, you can check whether m is equivalent to 7. If it is true, then we print something. C 99999. We can also make this because in mathematical this is equivalent. So do what equivalent here? And this is not printed because m is indeed 7. If you require m is not 7, this will false because m is 7, and hence this will not be. Yep. Branching. This is branching. What we call branching. And next week, about this time, we will talk about what we call thing, where we repeatedly do something similar over and over again. And then I will show what you can do with branching and looping being used together. So that's all for this session. And I don't see anyone watching this. Okay. So if you have any question, leave a comment down below, or I will get back to you within the week. And before we end this live stream, I would like to give a shout out to Trust Malaysia top new, located at rust-malaysia.github.io. We will be posting things about our meetups stuff in this blog, and our upcoming meetup is in May 8th of May at ways.ai. So if you are interested, the link should be posted to the blog shortly, or you can find the link in the description below. So if you are interested in meeting us or learn more about Rust or learn more about programming in general, please come and attend our meetup. I will soon. Thanks for watching. Bye bye.